Today we're going to be going over some practice problems revolving limits. So for our first problem, we are asked to find the limit of this function as x approaches 2. If we were to just do this regularly, you just plug in, x for 2 minus 4. That's how we usually solve something. This would be equal to 0. But on a lot of problems like number 2, we're going to have to learn to basically pick this apart. So x squared minus 4 would turn into, say, x plus 2 and x minus 2. I think that would be it, yeah. Let's just check just to be sure. Squared minus 2x plus 2x minus 4, yep. Those two cancel out, so if we were working on a problem like this, then we would separate an expression into this in order to, say, cancel things out. But regardless, we're still left with 0 for our first answer. Alright, so as x approaches 3, the limit of x squared minus 9 divided by x squared minus 5x plus 6. We're basically asked to find the limit as x approaches 3 of this expression. So as we were talking about before, we want to try to split both the numerator and the denominator to see if we can divide anything out. Because if we were to just plug in x for 3, we could just do 9 minus 9 over, I don't know, it's a bunch, but it's just going to turn into 0 divided by all of this, which is just going to be equal to 0. And that's not really like what we're going to get. So what we have to do is split this. You could usually just do it in your head, like if it's like x squared minus like a number that's divisible by itself or something else, then most likely you could just do it in your head. Okay, yeah, x plus 3 times x minus 3, because I just did it in my head. And this, we just have to complete the square for this, so we'd get both multiply this and this. Let's see, negative 3x and negative 2x. Alright, so then we just write it like this. Negative 2x plus 6, and it'd just be x minus 3, negative 2, x minus 3, and then that's going to be x minus 2 times x minus 3. And as we can see, we have two two expressions that are the exact same. We have x minus 3. We could divide these two out. And let's create some space. Actually, x minus 2. Alright, so we're just gonna basically have the expression like this now. x minus 3, or x plus 3 divided by x minus 2. And now that now that we have something we could use that doesn't turn into 0, we plug in x for 3. And we basically get 6 over, I think, 1, which is 6. Right there. Let's try some more intermediate problems. So, as x approaches infinity, we need to find the limit as um, we need to find the limit of this function as x approaches infinity. So obviously we can't just supplement x for infinity because how would that even work? So what we're gonna do is what we did before and try to pick both the numerator and the denominator apart. So as you can see, x squared minus 1, although you can't really, you could try to divide it. There's two equal divisible components, which is x squared. So we could just rewrite this as x squared times 1 minus 1 over x squared divided by x squared times 2 plus 1 over x squared. And we could just divide the x squareds out, so this would just end up looking like 1 minus 1 over x squared divided by 2 plus 1 over x squared. Just to give us some more space. Probably be too lazy to, probably won't edit this out honestly, but whatever. Alright, so 1 minus 1 over x squared divided by 2 plus 1 over x squared. So as so now we're going to try to apply the as x approaches infinity with these, because it's a lot more easier to find what the value of this function as x approaches infinity. As x gets bigger and bigger, like x squared, like let's say it's like 10 squared, 100 squared, or 1,000 squared, it just keeps increasing, and that slowly reaches 0, because it's literally just adding more and more zeros to this decimal, which is practically just 0 though. So we could just turn this into 1 minus 0 over 2 plus 0, which would make this whole thing equal to 1 over 2. Right? Just remove this now. Maybe I'll speed this up, who knows? I'll just leave it in the clip like this. Okay, so now we have the task of finding the limit as x approaches negative infinity of this function. Also be sure to try these before, if you guys think you've got this, maybe from like our past questions, you kind of understand what's going on. Be sure to try this and we can compare answers later on. Alright, so we have x to the third plus x squared minus 4 divided by 2x to the third plus x plus 11. What we could do, because we see the same thing as before, we see this x to the third. So we can change this denominator into x to the third times 1 plus x squared over x to the third. That's just going to be 2 over 3, I think. We could just write it later. X squared over x third. No. Minus 4 divided by x to the third. Divided by x to the third is 2 plus x over x to the third plus 11 divided by x to the third. We can just remove those x to the thirds and then we're just left with this. And as we said before, we could replace a lot of these for just 0 because this is just going to be, I think it's just 1 over x. I think this is just 1 over x. And this is just 1 over x squared. So all of these can be just represented as, like, as x approaches negative infinity, which is it's just gonna end up equaling 0. 0 is I don't think it's a negative or a positive, it's just 0. So as x approaches negative infinity, all of these are crossed out because they're zeros. So due to that, we're just gonna end up with we're just gonna end up with 1 over 2 because of all the zeros that we had to add and whatnot, and we already canceled out x squared. So yeah, this is gonna be 1/2 due to all the fractions that we would turn into 0 due to x being approaching negative infinity. So we're given more limit problems. The limit as x approaches 9 of this function is what we need to find. So let's take a look at the denominator and the numerator. Individually, as x approaches 9, the numerator is going to be equal to 3. As x approaches 9. And as x approaches 9, for the denominator, this is going to be equal to 0, since 9 minus 9 to the 4th is just going to be equal to 0. So we can't just plug in 9. So we're going to create a new limit that will help us take care of the denominator. So we're going to turn this function in terms of t. And we're going to do as t approaches 0 because with this is basically approaching 0 as it closes in on 9. And we're going to also make the denominator equal to t. So we're going to basically say the limit as t approaches 0 Square root of x is just going to be equal to t plus 9. It's just basic math you can do in your head. It's t true. This is basically the new limit that we have right now. And this is gonna, now we're gonna plug in 0, but only for the numerator. So it's just gonna be square root of 9 or 3 over t to the 4th. And as we said before, this is as x approaches, or this is as t approaches 0. So what this would look like is basically like 3 over 0. I don't know. We could do 1 or 0.001 left or right side. It's going to be increasing, I believe, fully. And it's going to grow without bonds, like either way. So it's going to end up becoming infinity because the value keeps increasing as t approaches 0. It is just going to be equal to infinity. So yep. Let's see here. Yeah, I'm probably not going to edit any of this out. Screw it. Maybe I'll speed it up or something. Who knows? Alright, so for our next problem, this is basically saying as x approaches 1, find the limit of x to the 4th minus 1 divided by x to the 3rd plus 5x to the 2nd minus 6x. So let us look at the numerator and denominator individually. Squared minus 6x. So before, when we were substituting for t, sorry, that was my hands. We did that because we didn't really have much of a choice in factoring anything out. But with this, we can actually take it by piece and hopefully factor out any polynomials. So this x to the 4th minus 1, we've said before, you know, x to the 2nd minus 1, x plus 1, x minus 1. So this is just going to be x to the 2nd plus 1, x to the 2nd minus 1. Wait, 1 second. Let me just move this for a second. Let's take care of the numerator first, and then we'll move on to the denominator. So it's going to be this, but we can take it down one more notch. So this would just be we would take this and basically turn it into x plus 1, x minus 1, and x squared plus 1. I believe. I think this is what we are going to get. Okay, this is going to be our numerator. X plus 1, x minus 1, x squared plus 1. We figured out the numerator, so just going to take this. Just going to move this to the side for now. Let's see here. Alright, wait, give me 1 second. No cuts. No cuts at all. Sorry, y'all, made a bit of an oopsie. We're going to be redoing the denominator. So, so we're going to take an x out, which is going to be, which is going to make it x squared plus 5x minus 6. Take these two. It's equal to 6x squared. And it's going to be 6 negative 1x. This is going to be equal to x squared plus 6x minus 1x minus 6, which is going to be x plus 6 negative 1 x plus 6. So it's going to, our denominator is going to be plus 6 x minus 1 and x. Let's give it more. Okay, there you go. So just make up some more room, you know. Alright, this is going to be our denominator. Let's write out the whole thing. So numerator x plus 1, x minus 1, x squared plus 1. And our denominator x plus 6, x minus 1, and x. We're going to be able to remove the x minus 1. And we can turn all of this, we can finally plug in x for 1. So it's just going to be 1 plus 1, which is going to be 2. 2 and plug in x squared for 1 squared, which is going to be 1 plus 1, which is 2. 2 times 2, which is equal to 4. And then we're going to have 1 times 6, which is 6, obviously. And this should be equal to 2 over 3, I believe. Let's see. Whoops, went too far. Let's go back a little bit. Whatever. One more time. Alright, so for our denominator, we're going to take this and multiply 1 out and should look a little something like x squared plus 5x minus 6. We're going to take these two end pieces, negative 6x squared. Let's see here. Alright, 6x and minus 1x. So this is going to be x squared plus 6x minus 1x minus 6, which is going to be equal to x plus 6 minus 1, x plus 6, be x minus 1, x plus 6, and an x as well, because we can't forget about that one we had at the end. Alright, so for our final answer, we're basically going to write out all of this. Let's say x plus 1, x minus 1, x squared plus 1, divided by x plus 6, x minus 1. I'm going to divide out these two. We can finally do that. And this is just going to be equal to 2 times 1 squared. 1 plus 1 is just going to be 2. I'm going to divide this, and we're going to say 1 times 1, I think 1 plus 6, which is just 7. So it's going to be 7. This is going to be your final answer. So now we're going to take a look at a few special cases. How to find the answer to this question. Pause and maybe take a look at it. Alright, so you might look at this and you might think, oh wow, this is a lot to do. I gotta find sine of 1, or maybe find a way to multiply it out, but in reality, all you're gonna do with this is just plug in 1 immediately. What you're left with is just ln sine of 1. Let's see. Let's do let's do something similar. And basically, this is just going to be going on forever and ever, so this is just going to be equal to infinity. Let's try to use an exponential value this time. Which is 1 plus 1. something like this, you would literally just substitute it once again. So this would just turn into limit to the second, or as x approaches 1, which is just going to be e to e squared. Try to do something a bit more complex. So you might be wondering, how the hell are we gonna get the limit out of this? Can't really do anything with it. So we're gonna take a look at the um Jesus, I'm forgetting the name. Uh the square or whatever like is here. I don't know the exact terminology, but whatever. We're gonna take x out of this. So this is just gonna be equal to x times 1 minus x. Let's ignore this. Just focus on 1 minus x. As x approaches infinity, this will just equal to 1 minus, 1 or 10, 100, 1,000, 10,000. It'll just be equal to negative infinity. It'll go on forever and ever. So this is just going to be equal to e negative infinity. And as anyone knows, the graph of e to the x is going to look like this. It's exponential, but it doesn't ever like cross the x-axis. And because of that, this is going to be equal to 0. And so that's going to be a few of the special cases that you might see on a future exam. It shouldn't be too bad. It's just, for limits especially, it's very simple. You just have to plug in most of the time, unless you have a polynomial, or I forgot the name of this, but whatever value this is, you have to figure that out. See what value it goes towards in order to fully find out what the limit is. So, yeah.